In this video, I'll be discussing the 5 basic types of reactions that we've gone over in class. First here, I'll talk about synthesis. I think that one is pretty easy to identify, and basically the whole point of this video is going to be to help you identify the main points of these. So synthesis, the big thing here, we've got 2 substances which are coming together to form one substance. And so the really big identifying factor of a synthesis reaction is that it has just one product here, just one thing on the product side. All right. For a decomposition reaction, it's the opposite of that. All right. The one way that you'll identify a decomposition reaction is it just has one thing on the reactant side, and that reactant is breaking down into 2 different products. All right. So in a synthesis means we're making something. All right. And so there's just one product. In decomposition, that means something is coming apart. All right, so we have one thing on the reactant side and it's breaking up into 2 different things. And so they're sort of opposites of one another, and that's how you would identify those. Single displacement, the way that this works is we have an element that comes in and it reacts with a compound, and that element is going to come in and it's going to displace something in the compound. And so in this instance, I'm showing A replacing B. All right, so A replaces B, A ends up with C, and then B ends up alone. And so the way to identify this one is we've got an element, and it reacts with a compound. That element takes the place of something in the compound, all right, and then some element is left alone in the end. And so we've got an element on the product side that's just a pure element, and on the reactant side, and we've got an element on the product side that is just a pure element. And that's how that one works. For double displacement, we've got a compound reacting with another compound. All right, and what happens is with this double displacement, we have 2 things sort of switching partners or switching places. And so in this case, it's kind of like the A and the C switch partners. The A ends up with the D, and the C ends up with the B. All right, or you could consider it's kind of the same thing, but you could consider the B and the D switching places. All right, the D ends up where B was, the B ends up where the D was. All right, but 2 things are switching partners here. And so you have a compound plus a compound yields a compound plus a compound, and 2 things switching partners there. The last one is combustion. Combustion is burning something, and the way that it always works is we have this hydrocarbon. Sometimes there's an oxygen thrown in with the fuel as well, but we've got this hydrocarbon fuel here. All right, and then it reacts with oxygen, and it creates carbon dioxide and water. For me, this is one of the easiest ones to identify because it always has oxygen, carbon dioxide, and water in it. And then we just have, the only thing that changes is whatever that hydrocarbon fuel is. All right, so it's going to be something with carbons and hydrogens in it for this fuel, or sometimes carbons, hydrogens, and oxygens. But you'll have the fuel changes. Everything else stays the same. And that's how we identify a combustion reaction. So giving you some basic things here, I'll review it one more time. A synthesis reaction, we have just one product. A decomposition reaction, we have just one reactant. For single displacement, an element comes in and it displaces an element within a compound. All right, so we get element plus compound yields element plus compound. All right, and then in double displacement reactions, you have 2 compounds reacting with one another, and they kind of switch what's in front or switch what's in back. You know, they change partners. In a combustion, we have that hydrocarbon fuel. It reacts with oxygen. We get carbon dioxide and water. Now what I have here is a series of practices on those, so you can kind of go through, pause the video if you want at different points, try and figure out what each of these are, but I'm going to go ahead and go through and do it basically in real time. So this first one here, NaBr, H3PO4, all right? As a compound reacting with a compound, it makes a compound and a compound, all right? So this one here is basically the sodiums and the hydrogens are switching partners, all right? Or you can consider the bromines and the phosphates are switching partners. And this ends up being a double displacement reaction, all right? We've got 2 compounds, it switches what's in front, and it's double displacement, switching partners. Number 2. Compound plus compound yields compound plus compound. it's another double displacement. All right, the calciums and the aluminums are just switching partners. Calcium was with hydroxide originally. Aluminum was with sulfate originally. In the end, calcium is with sulfate and aluminum is with hydroxide. So they switch partners. That is a double displacement reaction. This next one here, we've got magnesium coming in. That's an element. It's reacting with iron oxide. All right, that is a compound. The magnesium is displacing the iron. All right, so in this case, we've got an element coming in. It's reacting with a compound. The element is displacing one of the elements in the compound. Because you see here we get iron off by itself in the end. All right, and if that's the case, then what we're dealing with here is a single displacement reaction. An element comes in, it displaces something that's in a compound. So this is single displacement. Number 4, this one here we've got C2H4 reacting with oxygen. It forms carbon dioxide and water. This is a combustion reaction because we've got that hydrocarbon fuel. It reacts with oxygen. It produces carbon dioxide and water. So again, those are pretty recognizable because there's always oxygen there, there's carbon dioxide, and there's water, and then we have that hydrocarbon fuel on the reactant side. So combustion is what we end up with on this one. Problem number 5, we've got this PbSO4. That's the only reactant. It breaks down into these other things. If we only have one reactant, that should clue you into the fact that this is a decomposition reaction. We've got one thing, it's breaking down into other things. So this is decomposition. For number 6, NH3 plus I2 yields N2I plus H2. All right, this one's a little bit trickier because the elements are diatomic elements, but this is elemental iodine. All right, iodine coming in as an element. It's a diatomic element, but it's still an element. It's replacing the hydrogen here. Oops, that looks like it's pointing towards the nitrogen. The iodine is replacing the hydrogen. All right, and then hydrogen comes out as elemental hydrogen in the end, H2. And so we've got a compound plus an element. It yields a compound plus an element. All right, and so what this one is it's a single displacement reaction. Problem number 7, H2O plus SO3 yields H2SO4. All right, on this one again, something to notice, there's only one product here. If there's only one product, that means these two things are going to make that H2SO4, that sulfuric acid. And if you're just making one product in the end, it is a synthesis reaction. All right, on to the next one, number 8. O2 plus C3H8 yields H2O plus CO2. This one they're trying to be a little bit tricky about, all right, but hopefully you still identify we've got oxygen and a hydrocarbon here. It's reacting, it makes water and carbon dioxide, all right. That is a combustion reaction, all right. The only thing is just a little bit rearranged in terms of what falls in what place, but really with this, it's just like math. 2 plus 3 is the same thing as 3 plus 2. So on the reactant side, you can switch what comes first. On the product side, you can switch which comes first. And so they kind of can move things around. But we still have C3H8 reacting with oxygen. You're still producing carbon dioxide and water. It's just written in a slightly different arrangement. So that's a combustion reaction. For number 9, we've got NaOH plus KNO3. It yields NaNO3 and KOH. This one, it's a compound. It's reacting with a compound. It produces a compound and another compound. What's happening here is the sodiums and the potassiums kind of switching partners there. Sodium started out with hydroxide. Potassium started out with nitrate. In the end, sodium's with nitrate. Potassium's with hydroxide. So that is a double displacement reaction. For number 10, we've got CH4 plus O2 yields carbon dioxide and water. All right. Again, hydrocarbon fuel, oxygen, carbon dioxide, water. All right, so that is a combustion reaction. Fe plus NaBr yields FeBr3 plus Na. So in this case, we've got iron coming in as an element. It displaces the sodium, all right? And so iron ends up with bromine. The sodium ends up alone. Element plus compound yields compound plus element. This one here is a single displacement reaction. For number 12, CaSO4 plus MgOH2 yields CaOH2 plus MgSO4. All right, compound plus compound yields compound plus compound. Again, this is a double displacement reaction. We're just mixing what's matched with what. For 13, Na2CO3 yields Na2O plus CO2. This one, there's only one reactant, all right? And only one reactant means that it is a decomposition reaction. Pb plus O2 yields PbO2. This one, there's only one product. Okay, if there's only one product, that means it is a synthesis reaction. Both of these things are reacting together to make PbO2. So it's synthesis. Okay, I know that was pretty quick, but hopefully that little review and me talking through those different examples will help you to identify these different reaction types. As always, if you're confused by this, make sure that you stop in and ask.